Now, whenever they're asking us for the for one of the endpoints instead of the midpoint, we're going to use the midpoint formula, but we're going to use it differently. Okay? So let me show you this. I think the way we write the midpoint formula is pretty convenient, pretty easy to understand, fairly easy to use, right? That wasn't a whole lot of trouble. Now let's think of it this way. This right here, all of that together represents the x-coordinate of the midpoint, doesn't it? So if I rewrote my formula, instead of one formula where I have the x-coordinate of the midpoint and the y-coordinate of the midpoint in the same formula, if I separated that out, if I said xm, meaning x-coordinate of the midpoint, equals x1 plus x2 divided by 2, that would be correct, wouldn't it? That's not as convenient a way of writing the formula as we had it all in one parentheses, but that's the way you find the x-coordinate of the midpoint. Well, all of this over here is how we find the y-coordinate of the midpoint. So I can make a separate formula saying that the y-coordinate of the midpoint equals y1 plus y2 divided by 2. Now, I'm going to use each of these then, because what they're giving us is this is the midpoint. So I already know what xm is, don't I? It's 1, because 1's the x-coordinate of the midpoint. So I can come over here and I can replace xm with 1 equals, and then this point over here is one of the end points. So I already know what one of the x-coordinates of the, so either x1 or x2, doesn't really matter which one I call it, does it? Okay, so I'm just going to say that x1 is 6, and that's how I get that. Okay, now let me go ahead and set up the y-coordinate as well, then I'll show you how to solve these and try to make it make more sense. All right, so they tell me that the y-coordinate of the midpoint is 3.5. So replace ym with 3.5. They tell me the y-coordinate of that end point is negative 2. So replace y1 negative 2, like so. Okay? Now, the thing I'm going to do next is I'm going to multiply both sides by 2. And let me show you why that works and why the 2 disappears, goes away. No, those aren't good math terms. Gets divided out. Okay? The 2 gets divided out. If we had, let's say, 3 plus 5, we all know what that is. And then I was going to divide it by 2. But then I multiplied it by 2. So we know what 3 plus 5 is. We know what it is when we divide it by 2. We know what we get when we multiply by 2. We're back to just 3 plus 5, aren't we? Okay? So you're multiplying fractions is what you're doing. And when you multiply fractions, if you want, you can divide out a common factor from the numerator and denominator. Because anytime you see the same number, now it's got to be multiplication, only multiplication. But anytime you see the same number as a factor in the numerator and denominator, isn't a number divided by itself always 1? So see, the 2's divide out, leaving me with that. So that's the technique I'm trying to use right here. So I'm going to multiply both sides by 2 so that on the right side, the 2 in the numerator, which is a factor because it's multiplied by the rest of the numerator, divides out with the 2 in the denominator, which is a factor because it's multiplied by the other denominator. All right, so I'm dividing out factors, which leaves me with this. Okay, so does that technique make more sense to you now? Then you subtract 4 or subtract 6 from both sides, and that's the x-coordinate of your other endpoint. Then we use the same technique over here for the y. Multiply both sides by 2. And it's got to be both sides, doesn't it? Otherwise, I'm changing the value of things. So it's got to be both sides. I get 7 over here. These 2's divide out. Add 2 to both sides. And so I've learned that, is it G I'm looking for? That G has coordinates -4, 9. So if we look here at 12, we got the same thing going on, right? So they tell us that M is the midpoint, and it has coordinates 6, 4, and we know the coordinates of D, the honest-to-goodness coordinates of D, and they tell us the coordinates of C, but they're variable expressions. So we're supposed to find the value of A in this figure. So let's do what we did with 11. Let's do what the x coordinates first, okay? We can say that the x coordinate of the midpoint equals x1 plus x2 divided by 2. And let's substitute in what we have. So the x coordinate of the midpoint is 6 equals x1. It can either be 3a or 3, right? It's one or the other. Doesn't really matter. So which one do you want to make it, 3a or 3? 3 plus, then x2 has to be the x coordinate of the other endpoint. So x2 has to be 3a divided by 2. Make sense? Then we're going to multiply both sides by 2 to clear fractions. So 12 equals, those 2's divide out, 3 plus 3a. Subtract 3 from both sides. Divide both sides by 3. The question was, what is the value of A in the figure? Do we now know the value of A? We do. Do we need to bother going through this process with the y coordinates? We don't. Could I have done the y's instead of the x's? Yeah. I'll get 3 either way. But I don't have to duplicate it. I've done what they wanted me to do. I know what A is. I'm done. That one makes sense? I need you to go ahead and get out your compass and straight edge. Because we're going to be using it in just a minute. Yeah, we're still in lesson 3. Now, yesterday we talked about midpoints, like we just went over here. It's a middle point, right? It's the point halfway between the end points of a segment. Now, our learning target that we're going for here is I'm going to show you how to construct a segment bisector. Before we can construct a segment bisector, you need to know what a segment bisector is. So, in the book, on page 29, they tell us what a segment bisector is. They say that any segment, line, or plane that intersects a segment at its midpoint is called a segment bisector. So anything that goes through the midpoint of a segment is the bisector of the segment. Now eventually we're going to have angle bisectors as well, and we'll be able to tell from context if we're talking about a segment bisector or an angle bisector. Okay? We'll try to remember to be specific, but context is going to make things fairly clear with that. So what I'm going to teach you how to do here is to construct a segment that bisects another segment. Now, if I teach you how to do a segment, we can make it a line pretty easy just by drawing it as a line instead of a segment. So we're going to draw a line or a segment that bisects another segment. In other words, I said draw, didn't I? We're going to construct. So I'm going to teach you how to construct a segment bisector. Now, bisect means to cut into 2 equal halves. Okay? The definition says it goes through the midpoint, but you need to understand that going through the midpoint, since the midpoint's halfway between the endpoints, means that the segment or the line that we construct cuts the segment into 2 equal halves. So think of bisect as meaning cut into 2 equal halves. Okay? So the the definition's important. This definition is not a learning target. It's more important that you understand that when you draw a line through a midpoint, that line cuts the segment into 2 equal halves. Have I said that enough for that to sink in? All right, we'll see, won't we? All right. So, again, I think the directions in the book will make sense to you once I've shown you how to do this. Learning a construction from directions. Sometimes the directions make a whole lot of sense, sometimes they don't. So let me show you how to do it, and then you can look at the directions if you get confused, or you can watch this lesson again on iTunes U and get it down. All right, so here's what we're going to do. We need to start with a segment. So on your paper, construct a segment. That means use a straight edge. In a construction, nothing is freehand. Don't make the segment tremendously long. So that's mine. And I'm going to try to center it in my paper. That doesn't really matter. Now you're going to need a little room above and a little room below. And if you happen to mark over something you already have on your paper, so what? Okay? And let's label the endpoints of this segment. What do you want to call it? How about PR? We are going to construct the bisector of segment PR. We are going to construct a segment bisector of segment PR. See, there's several ways we can say the same thing. Here's what we do. We take our compass, and remember, compasses are measuring instruments. They're not for making circles very often at all. They're measuring instruments. And we're going to put our point at P. And I'm going to stretch the compass out so that it's more than halfway. Doesn't have to be all the way to R, has to be more than halfway. All right, mine looks more than halfway, doesn't it? Make sure yours is more than halfway. And then what I'm going to do is I'm going to come up here. Actually, not very far. I'm going to make an arc above segment PR. Then I'm going to twirl it around. And I'm going to make an arc below segment PR. Okay? Everybody got that? Now, I'm going to move my point over to R. Now, I'm going to change colors here so you can see where the arcs come from. You can't do that. Now, I'm going to make my compass cross the arc I have above segment PR. And I'm going to make my compass cross the arc I have below segment PR. Now, using your straight edge, we're going to make a segment that goes, well, in fact, I'm going to label this the intersection of the two arcs above the segment. I'm going to call A the intersection of the two arcs below the segment. I'm going to call B. Use your straight edge and construct line AB or segment AB. I don't really care which. So like so. Okay? Segment AB, or line AB, is the segment bisector of segment PR. All right? That means that that line AB cuts segment PR into two equal halves, two congruent segments. The segment bisector cuts segment PR into two congruent segments. Does everybody look that way? Okay. Now, this construction's probably the most important one we'll do all year because it's actually three constructions in one. Okay? We learned this as the construction of a segment bisector. Later on, we'll learn how to construct perpendicular lines. Guess what? Segment AB and segment PR are perpendicular to each other. So not only is this construction the way you construct segment bisector, it's also the way you construct perpendicular lines. And then later we'll learn something called a perpendicular bisector. Guess what? That's what we just did. Okay? Because the lines are perpendicular and AB is a bisector, and so it's a perpendicular bisector. Now, one thing I need to caution you about. PR is the one that got bisected, not AB. Okay? PR is the one that's bisected. Question? Because otherwise the arcs won't meet. Okay? All right, any other questions? All right. So the question was, in case y'all didn't hear, why do you have to stretch your compass out more than halfway? Because if you don't, then they won't intersect. All right? And, oh, you know what? I didn't emphasize it, but I guess y'all did it. Once I stretched the compass out more than halfway, I never changed the setting, did I? So don't change the compass setting once you have it more than halfway. Okay? All right. Anything else?